Welcome to the deep dive. Today we are cracking open some fascinating research that really challenges the foundation of modern AI search agents.
It does.
I mean, these language agents have shown incredible power. They generate complex code. They handle all this sophisticated information retrieval. They look like they've conquered the digital world.
On the surface, yes.
But all of that rapid progress, it relies on this core and, frankly, unrealistic assumption
A huge one.
that when you, the user, type something into a search bar, your query is already perfect. It's complete and totally unambiguous.
Which is almost never the case.
Right. So our mission today is to dig into the source material that shows just how far this assumption is from reality and uncover why this inability to handle ambiguity is, well, the newest and most critical blind spot in agent development.
This is such a crucial pivot point. In the real world, users almost always start a search with an incomplete or vague idea.
They're just exploring.
They are. They need clarification, but most search agents, they just don't have the tools to get that clarification once a search has started. So when they face ambiguity, they just confidently commit to one interpretation.
And that interpretation is almost inevitably wrong.
Almost always. To address this, the researchers introduced something called InteractComp. It's a new benchmark designed specifically to evaluate one thing.
Just one.
Can an agent recognize ambiguity, and then can it actively interact? So ask clarifying questions to resolve it during the search process.
Okay, let's unpack that.
Yeah.
We're used to seeing agents crush benchmarks like GAIA or BrowseComp. But the source notes that those tests kind of set the agents up for success because they provide all the resources up front. There's no need to ask for anything.
InteractComp completely flips that script. Its whole design principle is easy to verify, interact to disambiguate.
Okay, what does that mean in practice?
It means the questions have a short, verifiable answer like 1 or 2 words if the agent has enough context. But they are engineered to be impossible to answer confidently without asking for those missing details.
So how do you actually design a question that's intentionally ambiguous enough to trip up some of the world's best AI models?
They developed this brilliant technique. It's called the target-distractor methodology.
A trap.
Essentially, yes, a trap using shared facts. So the annotators pair a lesser-known target entity, let's say the unique Swiss sport, Hornison.
Okay, never heard of it.
Right, and they pair it with a very popular distractor like baseball.
I see where this is going.
Then they craft the ambiguous question using only the attributes that are shared between both.
For example.
Things like a team-based striking sport, offense-defense alternation, uses a high-speed projectile, requires protective gear.
If you search for that, you're only going to find baseball.
Overwhelmingly. The internet will confidently point you to the popular distractor, even though the real target was Hornison all along.
I love that. It is the ultimate stress test for an AI's confidence. So if search leads to the wrong answer, where does the agent get the real information it needs?
That's hidden away in what the paper calls the context. The context holds only the distinctive attributes.
The things that make Hornison, Hornison.
Exactly that. So the fact that the struck object is a plastic puck, or the striking method is a whip-like swing, or that the field is a giant fan shape with, like, 18 to 20 defenders.
So the agent is forced to perform an ask-question action.
It has to. It submits a yes-no question to a simulated user who only replies based on that hidden context. It's really simulating that feeling of searching for something and realizing your query was just way too broad.
And the data set for this is pretty substantial.
It is. 210 expert-curated questions across 9 domains, mostly science, humanities, and entertainment.
Okay, now let's get to the results, because this is where we see these striking failure patterns across all 17 models they evaluated.
And the research is definitive here. The problem isn't a lack of reasoning ability, it's a lack of caution.
So the capability is there.
It is. You can see it clearly in the performance ceiling finding. When they gave the agents the complete disambiguating context up front.
So they bypassed the whole interaction part.
Right. The best models, like one from OpenAI, achieved 71.50% accuracy. So this confirms they have the internal reasoning and search skills to get the right answer if they have the facts.
And here's where the floor just drops out. If they can reason at a 71% level, What happens when you make them responsible for realizing they need that context in the first place?
It's a disaster. In the full interaction setting where the agent had to do the whole answer, search, and ask process, the highest performing model, GPT-5, only got 13.73% accuracy.
13%.
And most other models were in the single digits. It's a dramatic 5x performance gap. A model that can reason correctly 7 out of 10 times falls off a cliff the moment it has to decide to ask a simple clarifying question.
That massive gap really exposes this core problem, overconfidence. They fail to interact because they just assume they already have enough information.
Yeah. And this overconfidence shows up in really strange ways when you look at how often they do decide to interact.
It's all over the place, isn't it?
It is. You see models swinging wildly between over-questioning and under-questioning, and neither approach seems to work.
So what's an example of over-questioning?
Well, take GPT-4 Mini. It used the interact action in a staggering 73.95% of the rounds it could have, the highest rate they recorded.
Okay, so it's asking questions constantly, but its accuracy
That is
was?
7.13%.
But wait a second. If an agent is asking clarifying questions 3/4 of the time, doesn't that suggest it is recognizing ambiguity?
That's a great point. It suggests that just asking questions isn't enough. It seems over-questioning without a clear purpose is just as bad as not questioning at all.
Because the low interaction models were just as bad.
Just as bad. GLM 4.5 interacted only 0.25% of the time, its accuracy, 7.14%. So the failure is twofold. A reluctance to ask, and then when they do ask, it's not strategic.
What was fascinating, though, was how interaction affected their self-awareness, their calibration.
Yes, the calibration error, or CE. It's the difference between how confident the model says it is and whether it's actually correct.
And more interaction helped with that.
It did. Models that asked more questions, even bad ones, showed better calibration. GPT-4 Mini's constant questioning didn't help its accuracy, but it brought its calibration error down to 37.44.
So it was less confidently wrong.
Much less. Compare that to a low interaction model like Dubo 1.6, which had a catastrophic calibration error of 84.35.
Wow.
So the mere act of interacting seems to force them to assess their own limits more realistically, even if they don't get the right answer.
So interaction helps the model realize that it's guessing, but it doesn't solve the core problem of getting the right answer. The ablation studies really hammered this point home.
They isolated it perfectly. When they ran the agents in an answer-only mode, just using internal knowledge, accuracy was terrible. GPT-5 got just 7.62%.
And what about when they added search?
This is key. When they added search-only capabilities, so letting the agent browse the web but still not interact, the benefit was tiny. GPT-5 only went up to 9.52% accuracy.
So just retrieving more information doesn't work.
It can't. If both Hornison and baseball show up in your search results for striking sport, search alone is useless. That huge performance gap between the 9% with search and the 71% with the full context proves that interaction is the single critical missing piece.
And the researchers also checked if just giving them more time or more computational runway would help.
Right, they increased the interaction chances from 5 rounds up to 20.
And even with 4 times the chance to ask, the agents were still reluctant.
Still reluctant. Despite the opportunity, GPT-5 only slightly increased its average number of interactions, from about 1.1 to 1.9. It's a failure of scaling that confirms the problem isn't time or capacity. It's a strategic programming failure.
Which brings us to the most conclusive finding, the forced interaction experiments.
This is where it all comes together. If the failure is strategic and not a capability problem, then forcing the agent to ask questions should dramatically improve performance.
Even if the questions aren't perfect.
Even then, and that is precisely what happened. When they compelled models to interact a minimum number of times before answering, accuracy saw these immediate dramatic gains.
How dramatic.
GPT-5 doubled its accuracy, from 20% to 40%, just by being forced to ask 8 questions. This proves, pretty conclusively, that the capability to reason with the information is there. It's robust. But the strategy to seek that information is just fundamentally broken.
This raises a really important question about where AI development is heading. If these models are getting smarter every month, why hasn't this been solved?
Well, the longitudinal study they ran provides a pretty jarring answer. Over 15 months of model development, they found a clear divergence.
A divergence between what?
Between performance on complete, unambiguous queries like those in BrowseComp and performance on these ambiguous interaction-dependent queries in InteractComp.
So on the old benchmarks.
Performance shot up, a 7-fold increase in proficiency over that period.
But on InteractComp.
almost completely stagnant.
Hmm.
Across all the recent sophisticated models like GPT-5 and DeepSeek-R1, accuracy is just stuck. It's clustered stubbornly around that 6% to 14% range, with almost no improvement over time.
So that divergence exposes interaction as this critical blind spot. All the progress in retrieval and reasoning just hasn't translated into an ability to recognize ambiguity and ask for help.
Not at all.
So what does this all mean for you, the listener? This research introduces a really crucial new metric for agent competence, one that moves beyond just raw information retrieval or complex reasoning.
Hmm.
It demonstrates that the best models we have today are fundamentally limited not by their knowledge but by a strategic failure, this systematic overconfidence that stops them from just admitting they're uncertain and asking for help.
And that strategic failure really is the last barrier. The forced interaction experiments prove the capability is already there, it's latent. The benchmark itself provides a clean reward signal, a short, verifiable answer. The challenge for developers now shifts entirely to training models to overcome that core failure of systematic overconfidence and actually engage with you when a query isn't clear.